Now, inverse. Inverse. If P then Q is a conditional statement, then inverse of P then Q is negation P then negation Q. Inverse of P then Q is negation P then negation Q. And it is read as not P then not Q. The truth table for this is truth table P Q. P then Q and negation P, negation P, negation Q, and at the last one is negation P then negation Q. Okay. Now here P is true, true, false, false, true, false, true, true. As we have already done from the beginning, when we have hypothesis is true and the result is false, then we have to write down false. Otherwise, in each and every P then Q will be true. True, true, true. Here our hypothesis is true, but the conclusion is false. That's why it is false, remaining all true. Similarly, now negation P means opposite of P. Here P we have true, write down false, true, false, false. We have to write down true. For the false, we have to write down true. Similarly, negation Q means here is true, write it down false. Here is false, write it down true. Negation means opposite. True, false, true, false. Now what we have to do? Not P then not Q. Not P then not Q. It is also similar with this, where now for us our hypothesis is this and the conclusion is this. Besides the hypothesis true and the conclusion false, all the relations are true. It is true, it is true. Here hypothesis is true, but the conclusion is false. When the hypothesis is true and conclusion is false, we have to write false, otherwise all true. So the result is T, T, F, T. This is how we have to construct, we have to draw the truth table of inverse. Now let's do contrapositive, the third one. Where if P then Q is a conditional statement, then contrapositive of P then Q is, contrapositive of P then Q is negation Q then negation P. And it is read as not Q, that, not Q, then not P. The truth table for this is truth table. Let's draw the truth table. Here P, here Q, here P then Q, negation Q, negation P, negation Q, then negation P. Okay. As we used to draw, we have to write down TTFF. Now TF, TT. As you are familiar with P then Q means if the hypothesis is true and the conclusion is false, the result is false. In all the cases beside this, result is true. Negation Q. Negation Q means opposite of Q. Here is true, write down false. Here is false, write down T. Here is true, write down F. Here is T, write down F. Similarly, negation of P means here is true, false, false, true, true. Now we need to find out negation, not Q, then not P. Negation Q, then negation P. Same from the same ideas applies over here also. If our hypothesis is true and the result is false, then the hypothesis is true and the conclusion is false, the result is false. Otherwise, in all the cases, it is true. This is how we have to do contrapositive of the biconditional. Biconditional. The biconditional of the statement P and Q is symbolized by P. It is symbolized by P and both sides implies Q, which means P then Q and Q then P. It means P then Q and Q then P. So while writing this in symbol, what we do, Q and Q then P. The logic of this is in biconditional, if P is by P then Q and Q then P is true when both P and Q have same truth value, and otherwise it will be false. That means if same value. Suppose if P is true and Q is also true, the result is true. If P is false, Q is also false, the result is true. In other cases, the results are false. The symbol, this suggests the combination of P then Q and Q then P. P then Q and Q then P. That's why what we write in truth table also, we should write P then Q and Q then P. Let's draw the truth table for this. Truth table. This is P, Q, P then Q, Q then P, and P then Q and Q then P. P then Q and Q then P. I think it will be better if we keep inside the bracket. So now P, true, true, false, false. Q, true, false, true, false. As we have already done, what P then Q. In P then Q, if our hypothesis is true and the conclusion is false, the result is false. Otherwise, in all, the result is true. Similarly, Q then P. Here in Q then P, Q is hypothesis and P is the conclusion. In Q then P also, if we have hypothesis is true and conclusion is false, then it is false. Here we have true, true. So TT, true only. Only TF is F, otherwise remaining all true. TT, FT. Now what we have to do? We have to do P then Q and Q then P. P then Q and Q then P. So in P then Q and Q then P, if both the result true, conclusion is true. If both the result is false, then the conclusion is false. Sorry, when both the result is true, conclusion is true. If both the result false, then also the conclusion is true. If hypothesis is true and the conclusion is also true, true. If here was hypothesis false and conclusion was also false, we could write true. But if P then Q and Q then P has same truth table, same truth value, then the result is true. If different like FT, then the result is false. If difference, the result false. If same, the result true. This is the truth table for biconditional. Biconditional means P then Q and Q then P. Now let's do tautology and contradiction. A compound statement is called tautology if it is true for the set of given compound statements. For example, let's consider a compound statement. It is only an example of compound statement. P and Q then P. P and Q then P. Let's draw the truth table. Truth table for this. P, Q, P and Q. Now P and Q, then P. Okay. T, T, F, F. T, F, T, F. Now see P and Q. In P and Q, we have done before also. If both the results are true, then the answer true. Otherwise, in all the cases, it is false. F, F, F. So P and Q is over. Now what we have to do? P and Q tends to P. So in tautology, if both the truth table hypothesis as well as our conclusion, if both the results are same, then we write true. Otherwise, P and Q, then P. In P and Q, then P, if we have TF, hypothesis is true and the conclusion is false, then the result is false. Otherwise, all true. Here, check. Hypothesis is true, conclusion is true. Hypothesis false, conclusion false. True. Hypothesis false, conclusion false. True. Hypothesis false, conclusion is also false. True. So in all we can see T, 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 T. So if all the values are true, then it is called tautology. Okay, let's do contradiction. A compound statement is called contradiction if it is false for all the given compound statement. For example, let's consider a compound statement. P comes P and negation P. Let's draw the truth table for this. Truth table. P negation P. So P negation P, P and negation P. So here true, true, false, false. True, true, false, false. So negation P is when here is true. Negation P means opposite of P. False, false, true, true. Now P and negation P. In case of and, if both are true, then the result is true. If any one is false, the result is false. Here, in none of these four statements, both are true. That's why all the results are false over here. Let's solve a question related to the topic logic. I have written a question over here. Construct truth tables for the following compound statements. Negation P and Q, negation P or negation Q, P then Q and Q then P. The first, let's construct a truth table for the first one. Truth table. Yeah. P, Q, negation P and Q. So P, true, true, false, false, true, false, true, false. So negation P means opposite of P. False, false, true, true. Opposite of T, false. Opposite of F, T. Now we have to do negation P and Q. When we do and, if both are true, the result is true. If hypothesis and the conclusion both are true, then the result is true. If anyone is false, then the result is false. So here we have only one in which both are true and the result is true, remaining all false. This is what we have to do for the first one. Draw the truth table for B number. Truth table. So in B, we have negation P, negation Q. So first of all, write down P, Q, then negation P, negation Q, and also one more table for negation P or negation Q. Now here, true, true, false, false, true, false, true, true. Negation P mean opposite of P, false, false, true, true. Negation Q, false, true, false, false. Now negation P or negation Q. In or, if at least either the hypothesis and conclusion, if one of them is true or both of them is true, then the answer is true, otherwise false. Here we need to find out negation P or negation Q. If one of them is true, then the result is true. If one of them is true or both of them is true, then the result is true, otherwise false. So F, T, T, T. Now the truth table for the third one. In third one, let's draw truth table. We have to find out P then Q and Q then P. So first of all P, Q, P then Q, Q then P, and at the last P then Q and Q then P. Okay. Okay, true, true, false, false, true, false, true, 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 false, true, false. Now P then Q. P then Q. If we have hypothesis is true and the result is false, then the answer is false. Otherwise in all we have true, true. Hypothesis is true and the answer is false, then the result is false, otherwise true. Similarly in Q then P. Q is hypothesis, P is result. If we have TF, then the result is false. In others, all are true. Now here at the end we need to find out P then Q and Q then P. In and, if both are true, true. If anyone is false, then the answer is false. Here in both are true, true. Here anyone false, here one is false, so answer is false. Here also one is false, the answer is false. Here both are true, so the answer is true. That's why the table for this is T, F, F, T. Now let's draw the truth table for number C. P then Q and Q then P. The truth table is P, Q, P then Q, Q then P, and at the end P then Q and Q then P. So true, true, false, false, true, false, true, false. P then Q. In P then Q, if we have hypothesis is true and the result is false, false. Otherwise in all cases true. Similarly in Q then P, Q is hypothesis and P is the conclusion. If hypothesis is true and the conclusion is false, false. Remaining all true. Now P then Q and Q then P. In and, if both the hypothesis and conclusion are true, the answer result is true, otherwise false. So F, F. Let's do one more questions. Negation P and Q implies P or Q. Negation. Let's do one more questions. Negation P and Q implies P or Q. Let's draw the truth table for this. Truth table. So negation P and Q. First of all, we need P, Q, P and Q, and then negation of P and Q, and the last one is negation, P or Q, not last one, the second last, and the last one is negation of P and Q then P or Q. Now for P, T, T, F, F, T, F, T, F. P and Q. In P and Q, if both the results are true, both hypothesis and conclusion, if both are true, otherwise false. So T, F, F, F. If both are true, then only true. Baki false. Negation of P and Q. Here is true, false. Negation of false is true, false, true, false, true. Now P or Q. In OR, if either hypothesis or conclusion is true, then result is true. Or if hypothesis, conclusion both are true, then also result is true. Beside that, in all results are false. P or Q. Hypothesis, result both are true, so true. Here at least one true, so true. Here also one is true, so true. Otherwise false. Now what we have to do? Negation of P and Q, then P or Q. In then if we have hypothesis is true and the conclusion is false, the result is false. Otherwise in all true. If TF, then only false. TF, TF here. If TF, it is false. Otherwise in all true. Dear learners, now we have completed the lesson. Now I have tried my best while delivering the lessons, and I hope you all have benefited after watching this video, and hope you all will be able to solve the questions which are related with the chapter sets. All the best for your exam. Thank you.